Hello, welcome. We are in Chapter 7, Part 2, and in this video we're going to be going through Lesson 7.3, Day 2, where we're going to continue talking about some logarithmic functions. On Day 1, we learned what a logarithm is and just some ways of converting between logarithmic and exponential form. Today, we're going to focus on graphs of logarithms. So we're going to take a look at some graphs here, as well as some domain and range. First, though, just a couple of things to note. One, logarithms are what we call inverses of exponential functions. So throughout this lesson today, we're going to see this relationship between logarithms and exponential functions. The inverse of an exponential function is going to be a log with the same base. So we have this exponential equation here. The base of this exponential equation would be 3. So if we wanted to find the inverse of that equation, we know the inverse would be y equals, and it's going to be a log with the same base. So if the base is 3, this log will also have a base of 3. So what we see here is this exponential equation would be the inverse of this logarithm and vice versa. So again, this has a base of 3, and we can see that those bases are the same. In our first example here, we're just going to compare the graphs of an exponential function and its inverse. So we have this equation, y equals 2 to the x power. Again, we know our base would be 2. And that's this curve here. So if I take a look at this curve here, this is the exponential function. And we'll take a look at domain and range. If you remember, in general, domain is the x values and range is the y values. If we think about the domain of this graph here, I do see that these arrows mean this graph keeps going. This graph will go to the left forever, and we won't be able to find where it stops. And this graph will keep moving to the right. So since it goes left and right forever, we would call that all real numbers. This is our symbol for that, or you could write out in words all real numbers. Range is our y values, which is up and down. So range, this graph will keep going up forever, but it will not keep going down forever. It might be kind of hard to tell, but this graph kind of bottoms out at 0 here. This graph isn't ever going to dip below 0. So it will go up forever, but it will not go down forever. We would say that's all real numbers above 0. You could use your symbol, or you could write, again, in words, all real numbers above or greater than 0. Now, the nice thing is the domain and the range for any exponential function are always going to be the same. It doesn't matter what this base is. It could be a 10, it could be a 22, it could be a 300. Our domain will always be all real numbers, and our range will always be all real numbers above 0. We have the inverse here. We see that the inverse is a log with the same base. So we see that the base is the same. And that's my other graph over here. So that would be this curve right here is our logarithm. We do see that these graphs are below 0. which means our domain would be all real numbers greater than or above 0. And our range is our y values. This graph will keep going down forever, and it will keep moving up forever. We can't tell how high or low it goes, so since it goes in both directions forever, we would call that all real numbers. And again, the domain and range for any logarithm are always the same. So the domain will always be all real numbers above 0. The range will always be all real numbers no matter what the base is. One thing you might notice is between the inverses, the domain and the range actually switch. And we see that because they're inverses or opposite of each other. So we'll see that those just flip when you're finding the domain and the range of the inverse. Those just flip from the original function. All right, in example 2, we're going to create a graph ourselves. So we're going to look at this equation here, which is an exponential function. We see that the base is 3. So if the base is 3, we're going to go ahead and take, these are my x values, so I'm going to go ahead and plug those in for x. So to find this y value, we'll do 3 to the negative 2 power. And we could simply evaluate that on our calculator in order to figure out what that is. It's okay that it's a decimal. We'll go ahead and just put a couple of decimal points. We're just trying to get an approximation. Here we could plug in -1, so I could do 3 to the -1 power. Again, a decimal, we'll just put a couple of decimal points. We'll do 3 to the 0 power. Anything to the 0 power is just 1, so that will be 1. We'll do 3 to the first power, which is 3, and 3 to the second power, which is 9. So this gives us 5 points that we could go ahead and plot on our graph. So I'm going to plot -2.1. I know that's a decimal, so I'm just going to get really close to where I think that is. Again, we're just trying to get a rough picture. It doesn't have to be perfect. We'll plot -1.33, 0, 1, 1, 3, and 2, 9. And then we'll go ahead and connect those with our curve. You can see that this looks very much like the exponential function that we saw in our first example. All exponential functions are going to kind of look like this. Then we're asked for the domain and the range. Again, every exponential function has the same domain and range. It doesn't matter what the base is. So my domain is going to be all real numbers, and my range is going to be all real numbers above 0. Then here we're asked for g -1. In our last chapter, we learned that that's the symbol for inverse. So this is asking us to find the inverse of g. Since this is an exponential equation, we know that the inverse is a log with the same base. So since our exponential function had a base of 3, we know that our logarithm is going to be the same. Now, inverse just means opposite. So for the inverse, what we're going to do is we're just going to switch the x and the y. So for the inverse, we'll go ahead and switch these in order to graph. Which means this will now be my x value and this will be my y value. So I'll plot 0.11, -2. Again, we'll just estimate for that decimal. 0.3, -1. 1, 0, 3, 1, and 9, 2. And we'll connect those with a curve. Again, we'll see that looks very similar to the logarithm that we saw up here. And again, these two graphs do look like inverses of each other. They look like they're reflections across that diagonal line, which is what we would expect. And if you remember, for the inverse, the domain and the range are just going to flip. So my domain will be all real numbers above 0, and my range will be all real numbers. So again, those domain and range will not change no matter what the numbers are that we're working with. All right, the very last thing that we're going to take a look at with graphs is actually just working backwards and coming up with a logarithmic equation from a graph. Anytime we look at the graph of a logarithm, there's going to be 2 points that we will always assume will be on the graph. One is this point 1, 0. So we're going to have this point 1, 0. And this just helps us decide if any transformation took place, as in, did we slide this graph to the right or to the left at all? If we see 1, 0, then there won't be any transformation. But if it's 2, 0, we know it moved over. Or if it's -1, 0, we know it moved. The other point is going to be a number with 1, whatever the y value of 1 is. That's going to help us determine our base. So whatever this number is next to 1, that's going to give us the base for our logarithmic equation. So if we take a look at this example here, I'm going to check those 2 points. One is the point 1, 0, which I see. And since we have that point 1, 0, that means there were no transformations. We didn't slide right or left at all, so we don't have to worry about that. The other point I'm going to look for is that point at 1. So I'm going to kind of draw until my graph connects. So I see that's the point 3, 1. And the number there is 3, so that's going to be my base. So when I write this equation, this will be y equals a log, and the base is going to be 3, since that was the point that I had on my graph. So this would be my equation for this graph. So really all we're doing is just finding that base that goes with the logarithm.